the infinite series 1 over n. So when n is 1, we get 1. When n is 2, we get 1 half. When n is 3, we get 1 third. When n is 4, we get 1 fourth, and so on. This type of infinite series, it has a name. It's called harmonic series. And so we have this harmonic series right here. And so we add all these values up, 1 plus a half, plus a third, plus a fourth, plus a fifth, and so on. And we want to show that this harmonic series diverges. And when we add them all up, is equal to infinity. And to show that the harmonic series diverges, first we'll form some partial sums. So s sub 2 is just the sum of the first two terms. S sub 4 is the sum of the first four terms. S sub 8 is the sum of the first 8 terms. S sub 16 is the sum of the first 16 terms. S sub 32 is the sum of the first 32 terms. And so for S sub 2 and then S sub 4, 1 plus a half plus a third plus the fourth, this is greater than, if we change this 1 third to 1 fourth, we know that 1 third is greater than 1 fourth. And therefore the sum of 1 plus a half plus a third plus a fourth is greater than the sum of 1 plus a half plus a fourth plus a fourth. And so here we have 1 half, and then a fourth plus a fourth is also a half. So a half plus a half is 2 halves. So we end up with 1 plus 2 halves. And so S sub 4 is greater than 1 plus 2 halves. And now let's look at the sum of the first 8 terms. And then right here, we change this to 1 fourth. And again, we know that 1 third is greater than 1 fourth. And then we're going to change these 3 right here to 1 eighth. 1 fifth is greater than 1 eighth. 1 sixth is greater than 1 eighth. 1 seventh is greater than 1 eighth. So the sum of these 8 terms is greater than the sum of these 8 terms. This is 1, this is a half. A fourth plus a fourth is a half. And this is 4/8, which is also a half. So we have 1 plus a half plus a half plus a half. So we have 1 plus 3 halves. 3 halves. Now look at the S sub 16, or the partial sum of the first 16 terms. And so this group right here, we're going to change that to 1 fourth. And then the next group, these right here, we make all of these 1 eighth. And then make all of these 1 16. So we have 1 fourth, 1 fourth, and then 1 eighth, 1 eighth, 1 eighth, 1 eighth. And again, all of these will be 1 16th. Again, this 1 third is greater than this 1 fourth. And then 1 fifth is greater than 1 eighth, 1 sixth is greater than 1 eighth, 1 eighth, 1 seventh is greater than 1 eighth. And then 1 ninth is greater than 1 16th. And the same thing here. So the sum of these 16 numbers is greater than the sum of these 16 numbers. This is a half. This group right here is a half. This group is 4/8, which is a half. And then this group right here, this is 8/16, which is a half. So we have 1 plus a half, a half, a half, and a half. So 1 plus 4 halves. And then let's look at one more case. This is S sub 32, which is the sum of the first 32 numbers in the sequence. And again, we'll, these right here, we'll change them to 1 fourth and 1 fourth. And then this group, we'll change it to 1 eighth. And then this group, we change them to 1/16. And then this group right here, these 16 numbers, we change them all to 1/32. This is the half, it's 2/4. This is 4/8, so it's a half. This is 8/16, so it's a half. And this is 16/32, so it's 1/2. So we have 1 plus a half, a half, a half, and a half, which is 1 plus 5 halves. In summary, we have s sub 2, which is the same as s sub 2 to the first, is equal to 1 plus 1/2. And then s sub 4, which is s sub 2 to the second, is greater than 1 plus 2/2. S sub 8, which is the same as s sub 2 to the third, is greater than 1 plus 3/2. S sub 16, which is the same as s sub 2 to the fourth, is greater than 1 plus 4/2. And then s sub 32, which is the same as s sub 2 to the fifth, is greater than 1 plus 5/2. So in general, we have s sub 2 to the n is greater than or equal to 1 plus n over 2. And therefore the limit of this sequence, the sequence s sub 2 to the n, is greater than or equal to the limit as n approaches infinity of 1 plus n over 2. And so as n runs to infinity, we get 1 plus infinity over 2, which is 1 plus infinity, which is equal to infinity. So this says that the limit as n approaches infinity of s sub 2 to the n is greater than or equal to infinity, which means that the sequence s sub 2 to the n diverges and the limit of s sub 2 to the n is equal to infinity. And now let's compare this sequence, the sequence of s sub 2 to the first, s sub 2 to the second, s sub 2 to the third, s sub 2 to the fourth, s sub 2 to the fifth. This in itself is a subsequence, it's a sequence. And so the sequence with the two terms, the first two terms, first 4 terms, first 8 terms, first 16 terms, and so on. This sequence is a subsequence of the original sequence. Each element that's inside this subsequence is also in the original sequence. Like s sub 2 is in the original sequence, s sub 4 is in the original sequence, s sub 8 is in the original sequence. So we call this sequence right here, we call it s sub 2 to the n sequence, is a subsequence of the sequence s sub n. And the sequence s sub the sequence s sub n is just the regular sequence of partial sums. And we have a theorem that says if a sequence converges, then all subsequences have to converge to the same value. And the contrapositive of that, which says that if some subsequence diverges, then the original sequence also diverges. And up here we have shown that this subsequence diverges to infinity, and therefore the sequence s sub 1, s sub 2, s sub 3, s sub 4, and so on, the sequence s sub n also diverges. So one more time, the subsequence s sub 2 to the n diverges, and the subsequence s sub 2 to the n is a subsequence of this sequence, and therefore this sequence also diverges. And since the sequence s sub n diverges, that tells us that the limit of s sub n, which is equal to the harmonic series, diverges. And so the infinite sum of 1 plus 1/2 plus 1/3 plus 1/4, 1/5, and so on diverges to infinity.